Lecture 9 will be among our shorter pre-lectures. We're going to continue talking about molecular structure. So to get going here, by the end of the class, between our pre-lecture and lecture, should be able to describe the difference between single, double, and triple bonds based on their bond lengths. Should understand what resonance structures are and how to draw Lewis structures that have resonance. You should understand what formal charge is and how we use it to help us determine what the most correct Lewis structure is. We're going to talk about formal charge in class tomorrow. Okay, just a reminder, one of the things I'm expecting you to learn this week are the polyatomic ions. So you have the whole week to get this chart kind of memorized. We'll tell you on quiz number 3, you will have at least one of these polyatomic ions, and you're either going to have to name it or provide the molecular formula for it. Okay? The one that you don't need to know is thiosulfate. You can cross that one off. The rest of these you should know, both the name, molecular formula, and the charge. Okay? All right. So let's get into bond lengths. And so we know already, we've talked about in class, that molecules can have single, double, or triple bonds. And as a molecule has more bonds, the atoms are going to pull closer and closer together. So in this example, we can talk about these 5 molecules. These are all molecules with just carbon and hydrogen. And we can see that our carbon-carbon bonds have varying lengths, depending on what kind of molecule it is. However, our carbon-hydrogen length is quite similar for most of these. There's a little bit of difference in acetylene, but the 3 I want to pull out here are ethane, which is shown down here, ethylene, that has a double bond, and then acetylene, which has a triple bond. So you can see as our bond order increases, as we go from a single bond to a double bond to a triple bond, we get closer and closer between our carbon atoms. So our bond lengths get shorter and shorter. These bonds also become more and more difficult to break then. Okay, so that's the difference between single, double, and triple bonds. Basically, single bonds are the longest, triple bonds are the shortest, double bonds should be somewhere in between. Okay. Another topic I want to talk about related to Lewis structures are resonance structures within Lewis structures. And so, say you have the molecule SO2 that I believe we at least mentioned last class. And in SO2, you can draw a structure where you have a double bond on this oxygen, or you can draw a structure where you have a double bond on this oxygen. And if we ask which one of those is more correct, the answer is yes, they're both equally correct. And so within that, we can say that we could draw either, and we represent resonance with this arrow here. Now, interestingly, neither of them is fully correct, in that the truth is that each SO bond is actually closer to being a 1.5 bond than purely a single bond or a double bond. And so we, of course, have trouble representing that with just drawing things out. So that's why we draw resonance forms. And so if I were on a quiz to ask you to draw a Lewis structure, including all the resonance forms for SO2, you would want to draw both of these structures with a double bond on oxygen on one and your double bond on the oxygen opposite for the other. Okay? I will say the only difference between the molecule shown here and molecules in resonance structures is the placement of double bonds. So they're going to have the same number of electrons, they're going to have the same ordering of the atoms. The only thing that is changing is where our double bonds are. Okay? All right, that is going to be all we're going to talk about in the pre-lecture. I hope that was useful. But please let me know if you have any questions. Otherwise, I will see you in class.